Good afternoon everyone. Today we are explaining about the project on quicksort visualization game using quicksort algorithm. This quicksort sorting is a way to arrange things in order, like putting numbers from the smallest to biggest. Quicksort is a smart and fast way to sort a list. It works by picking one number called a pivot and then moving small numbers from one side and bigger numbers to other. This happens again and again with smaller parts of the list until everything is in order. Next, we are explaining about the concept on uh, abstract this project. The sorting algorithms are a core component of computer science, are essential for understanding data structures and algorithmic efficiency. Among them, Quicksort is one of the most widely used and efficient algorithms, yet we can be difficult to grasp due to recursive nature and partitioning logic. Next, to address this challenge, this project presents Quicksort visualization games, an interactive and educational tool designed to help learners understand the working of this Quicksort algorithm through gamifications. Whether this project allows user to visualize and interact with the sorting process by selecting pivots and partitioning elements and recursively sorting subarrays in a game-like environment. Users can either manually perform the sorting steps or watch an automatic step-by-step visualization. The visual interface represents array elements as dragged blocks, making the learner's experience engaging. The innovative sorting hints and progress indicators enhance user motivation and learning through practice. Next, we are explaining about the introduction of a project. What is mean by Quicksort visualization game is an interactive educational tool designed to help users understand the Quicksort algorithm through dynamic graphical representations. Next, Quicksort is widely used in efficiently sorting technique based on the divide and conquer principle, where the array is partitioning into smaller subarrays around a pivot element, which simplifies the sorting process. However, the abstract nature of these algorithms often make it difficult for beginners to grasp it working fully. These visualization games addresses the challenges by providing step-by-step animated display of how an algorithm operates on a data set. Next, users can see how elements are compared, swapped, and how recursive partitioning progresses in real time. The game interface typically consists of colored bars or blocks representing an elements with highlights indicating and pivots, comparisons, and sorting portions. Next, these color coding and animations provide innovative feedback that bridges the gap between the concepts and practical understanding. Additionally, the game allows user to input customs and generate random data sets, making it flexible for various learning scenarios. Next, we are explaining that briefly introduction. It works by selecting pivot element and partitioning array into subarrays which can sorted recursively. While Quicksort is conceptually simple, understanding its recursive behavior and partitioning process can be challenging for beginners. To address this, the Quicksort visualization game has been developed as an educational tool that combines interactive gameplay with algorithmic visualizations. The game allows users to sort arrays step by step using quicksort algorithm principles, helping them understanding key concepts such as pivot selections, element swapping, and recursion. By engaging users in an interactive environment, the game aims to make learning quicksort innovative, effectively, and enjoyable. Next, we are explaining about the uh, brief objective of project. First, we can understand the concept of quicksort help players grasp how quicksort works, including the divide and conquer strategy and all use of pivot elements. Next, visualize the parsing process, show how arrays are split into subarrays based on the comparisons with the pivot. Next, identify pivot selection techniques, how the pivot can be selected or allow players to experiment with the different pivot strategies. Next, demonstrate recursion, illustrate how recursive cells are made to sort subarrays and how the entire array becomes sorted. Next, encourage algorithmic thinking. Next, engage players in choosing correct pivot and predicting outcomes of each partition step. Next, interactive sorting practical uses drag and drop click elements to steal the quick sort process themselves. Next, we are explaining about the problem statement of this project. Wrong statement. Next, understanding sorting algorithms are especially quicksort can be challenging for students due to its recursive nature and abstract logic. Next, the traditional teaching methods such as textbooks and lectures often fail to effectively demonstrate how quicksort operates step by step because it is very tough to understand the concept of quicksort. Without interactive visualizations, learners may struggle to grasp key concepts like pivot selections, partitioning, and recursion. Next, this gap is in understanding can hinder students' ability to implement or analyze sorting algorithms in real-world applications. Next, to understand this, there is a need for engaging and educational tools that will not only visit the quicksort algorithm but also allows user to interact with the control of the game process. By turning algorithm learning into an interactive game, we can enhance concepts, boost engagement, and provide a hands-on learning experience and reinforces knowledge. Next, we are explaining about the how data. This is the data flow diagram of my project. Next, we are explaining about the algorithm. Firstly, step 1 determine pivot. Next, step 2 start pointers at left and right. Next, step 3 since 4 less than 5 shift left pointer. Next, step 4 since 2 is less than 5 shift left pointer since 6 is greater than 5 stop. Next, step 5 since 9 is greater than 5 shift right pointers. Next, since 3 is less than 5, stop. Next, step 6, swap values at pointers. Next, step 7, move pointers one more step. Next, step 8, since 5 is equal to 5, move pointers one more step and stop. This the steps was going on these algorithms. Next, we are explaining about the flow chart, how flowchart works and designs the flowchart. Next, mainly we was explaining about the conclusion, how the quicksort algorithm works. The quicksort visualization will effectively transform the complex quicksort algorithm into an engaging and easily understandable learning experience. Next, by visualizing, demonstrating each step of the algorithm from selecting the pivot and partitioning the array to recursively arrays, sorting subarrays. Next, this tool helps user to grasp the core principles of divide and conquer sorting methods. Next, the dynamic animations, colored coded highlights, and interactive controls make it easier for learners to follow the sorting process and internalize how quicksort effectively organizes data. Next, this hands-on approach encourages active participations and experimentations, which are essential for deepening comparisons and retention of algorithmic concept. And furthermore, the visualization games serves as a bridge between theoretical knowledge and practical applications, allowing students and others to observe the algorithm's behavior with different sets in real time. Next, by simplifying abstract programming ideas into a simple construct visual format, the project supports the learning styles and full host of curiosity. Additionally, Quickstart Visualization game has to expand with additional features such as adjustable speed, input customizations, and challenges to further enhance user engagement. The dynamic animations, color coded highlights, participations, and experimentation, essential deepening comparisons, and retention of organisms. This is most important for the students to help these algorithms, how Quicksort works, and how the Quicksort game will works. This is most important. Next, this is how my project user interface can be displayed in the screen. How the quick input you should give input like descending order or ascending order. It will give order in a ascending orders. Next, thank you for giving. Thank you for your time, attention, and interest in this project. I hope the Quicksort Relations games provided a clear and engaging way to understand the Quicksort algorithm. I am happy to answer any questions or hear your feedbacks. Thank you.